Hello, this is Mr. Gilmore with the 2.3 Proof Setup lesson. Today we're going to be looking at what do we do to start a proof off. There is some structure we have to establish before actually jumping into the proof of a theorem. Here's the most common way to set up a theorem. We're actually going to dive into these three steps more specifically. Let's take a look at the overview. Step number one, write the theorem in a conditional form. We've been seeing conditional forms for the last two lessons, this if given then conclusion. So if the statement is not in the if then form, we will transform that into the if then form. Number two, typically draw and label a diagram. Now, I say typically here because there will be some, and I mean maybe a handful of theorems in which a diagram is not required, which means we do not need to draw a diagram for that proof. And then number three, we write the given and then on a new line, we write what we want to prove. These are actually going to be specific to the diagram that we have constructed. We want to make sure we reach the conclusion with the diagram in place so the reader can follow along with our diagram and know where we start and where we end. So again, our step one is the conditional form. We want to make sure it's written in if-then form. So for example, we're going to have a statement of proving that vertical angles are equal. Well, let's transform that into a conditional. If two angles are vertical, then they are equal. What that provides us with is where we start in our proof. That's going to be our given, and they are equal. That's going to be what we are to prove. Now, of course, we want to draw a diagram. So if we use our illustration again of vertical angles, what I need to do is then produce a diagram of vertical angles. Now, I will be labeling that diagram so that I can name the pair of vertical angles in which that I am going to prove. Again, not all proofs will require a diagram, but most will. And then step three, we're going to provide the given and what we are to prove. But these statements we make will be specific to the diagram. So you'll see here in just a moment when we set up an example that I will make a given and a proof statement that I'm going to pull right from the diagram that I've constructed. And I'm going to refer to those objects specifically. So make sure that if your diagram is not labeled enough, basically meaning that I cannot label or name all the objects that I need for the proof, I need to go back to my diagram and label those additional figures. So let's set it up. Let's go to this proving that vertical angles are equal. Let's start there. Now we've already seen this conditional, right? It was if two angles are vertical, then they are equal. So I'm not going to rewrite that. But where I'll start is at step two, which is let's draw a diagram. So I'm going to produce a diagram of vertical angles. Now, by definition, two vertical angles are angles in which their sides form two lines. So there we have it. I'm at two lines here. Now, with vertical angles, I get a BOGO, right? Buy one, get one free. Not only did I create one pair of vertical angles, but I created a second. I only need to refer to one pair of these. So let's refer to these two angles here, angle 1 and angle 2. So what am I given now, right? This is where I transform this diagram into some specifics. What do I start with and where do I end in the given statement and in the prove statement? So what am I given? I'm given that angle 1 and angle 2 are vertical. That's where we start. That's what our given is, if two angles are vertical. Okay, well, here are two angles, angle 1, angle 2. Notice I'm referring specifically to my diagram. I'm labeling the figures and naming those in my given statement. What do I want to prove? Well, think about what the conclusion is. Then they are equal. Well, what are the they? They are the vertical angles. I need to make those specific. So what are we going to prove? We're going to prove that the measure of angle 1 is equal to the measure of angle 2. And that is a very important part in setting up a theorem, is this setup that we do right in the very beginning, where we state our conditional, we deliver a diagram, and then we transform that diagram into specific givens and conclusions, which is these given and prove statements here. Let's do one more example. You will see this one come up later in this semester. Prove that the sum of the angles of a triangle is 180 degrees. Now, I'm not going to write the if-then form out, but here's what it would say. I would say if a polygon is a triangle, then the sum of its angles is 180 degrees. So I know that my given is a triangle, and my conclusion is that their sum of its angles is 180 degrees. Alrighty? So moving then from the conditional to a diagram, I need to provide what is in the given. Well, it's simply a triangle. Now, the thing about this triangle is we don't know really anything about it, other than that it exists, and it's a triangle. So we don't know anything about its sides or anything about its angles. One thing I will need to do, though, is label the vertices of that triangle so that I can name that triangle. Now, what am I going to then do for my given and proof statement? I'm going to transform from my diagram again to a specific given statement and a specific proof statement that follows my conditional. So my conditional is if a polygon is a triangle. So what am I given? I'm given a triangle. So I'm given triangle A, B, C. That's what I have. I don't know any more or less than that from the given. What am I then to prove? I'm proving then that the sum of its angles is 180 degrees. So I would write the measure of angle A plus the measure of angle B plus the measure of angle C, those three interior angles there, are summed to equal 180 degrees. And that is my setup. You will be practicing this setup on the worksheet. If you do have any questions, please do not hesitate to email me. With that, be good and do good.